Today we're going to talk about this problem. It's 2007 AMC 10A problem 15. So, 4 circles of radius 1 are each tangent to 2 sides of a square and externally tangent to a circle of radius 2 as shown. What is the area of the square? So firstly, we're gonna do some lines. We're gonna draw some lines on the diagram to help us figure out this problem. So my thought here was that we plot out the 4 tangent points, and then we can connect the points to form a square. So it's a square, but my drawing's not that good. So since we have a square, then basically we can extend these 2 sides, and then the side length of the circle is basically this blue side over here. However, that thought was proved to be wrong since I got the wrong answer for the problem. And then the reason here is because if you look at this part where I connected this line and reached it to the side of the square, this segment here is actually not part of any circle, so you can't use the radius to calculate that. So here's the correct method. So basically you have the radius of each radius 1 circle. So we just plot that out approximately, and then we use the radii, plural for radius, the radii to form a square. And this square we know because this is the radius of a radius 1 circle, and the radius 1 circle is externally tangent to the sides of a square. Then we know that at this point, if you extend this line here, it will definitely be part of the circle's radius and also touch the side of the square. So now we have this graph here, this square here. We know that the side length is basically just 1. The side length of the actual square is basically just 1 plus this part, let's call this k plus 1. So it's basically, the side length is basically k plus 2. So now we've got an idea of our square. We can try to solve for the side length, and we can use the information we already know. So what do we already know about the square? We know that it has a diagonal length of 6. So how do we know that? If we just zoom in here, then you see that this part is the radius. Let me use a different color. This part is the radius of the small circle, and this is 1. This section is the radius of the big circle, that is 2. So half of the diagonal, oh wait, what did I do? So half of the diagonal is 3, so the whole diagonal is 6. So we have half of the diagonal being 3, which means that this half of the diagonal is also 3, and we understand that this is a right angle because the diagonals basically split the square up into 4 equal halves, 4 equal triangles, which are congruent. You can prove that yourself, but the AMC will just assume that's a right angle. And if we use the Pythagorean theorem, we'll get the side length. So the Pythagorean theorem, the side length would be 3 squared plus 3 squared root. So we'd get 9 plus 9 root 18, which is equal to 3 root 2. So the side length is 3 root 2. So the side length of the large square is going to be 3 root 2 plus 2. The side length of the large square is going to be 3 root 2 plus 2. So yay, we're done with the problem. Well, not quite. We're not actually done because it says what is the area of the square. So we have to square this value because it's a side length. And if we expand that, we have 18 plus 2 times 2 times 3 root 2. So we have 12 root 2 plus 2 times 2 is 4. So we get 22 plus 12 root 2. And that indeed And that indeed is the correct answer. So we choose it, and we're done with this problem. So in this problem, it is important to choose to solve for the right side length using the information of radii. If we choose a wrong circle like I did in my first approach, then we'd end up with a wrong answer, and believe it or not, it's actually in the answer choices, it's 32. So it's important to choose the right side length and also confirm about whether our assumptions are true in the first place. So thanks for watching. I hope you learned something today and improved your AMC scores by this video. So bye, see you next time.